Have you ever noticed that the open file window looks almost identical whether you're using Windows 98 or Windows 11? That's not an accident. It's not Microsoft being lazy. It's actually a brilliant system called DLLs, Dynamic Link Libraries. And today, you'll understand exactly how they work, even if you've never written a line of code. Imagine every single app on your computer had to write its own code for common things, like opening a file, printing a page, or searching for text. Notepad would need it. Calculator would need it. Your web browser too. That means the same code stored hundreds of times, wasting storage and memory. That's how software worked in the very early days. But then Windows got smarter. So Windows created DLLs, Dynamic Link Libraries. Think of a DLL as a public library. Instead of every app owning a copy of a book, they all share the same one. The most famous example, COMDLG3 to .dll, short for Common Dialog. Inside that one file is the code for open file, save as, print, and find boxes. And Microsoft isn't the only author. Other companies make DLLs for things like PDF printing or zip compression. But how does an app know exactly how to ask the DLL for help? That's where the API comes in, Application Programming Interface. The API is like a restaurant menu. It tells the app, here are the available functions, here's what parameters to send, and here's what you'll get back. Every DLL publishes its API so any app, old or new, can talk to it without confusion. Here's the cool part. The app calls the DLL function by sending a digital command, like show me the open file box, only show Word documents. The app also says, when you're done, give me back the file path as text. Then the app basically goes to sleep. The DLL takes over. It talks directly to Windows, and Windows talks to your mouse, keyboard, and hard drive. At this moment, the DLL, not the app, is running the show. When the user picks a file, the DLL puts the result, for example, the full file path, into a shared memory location. Then it tells Windows to remove the DLL routine from memory to save resources. The app wakes up, checks that memory location, and sees success or sometimes failed. If it worked, the app continues. If it failed, you get that friendly error message, could not open file. Now, the old way had a problem called DLL Hell. Imagine an app installs a newer version of a shared DLL, and an older app stops working. Total chaos. Modern Windows fixes this with side-by-side assemblies. Each app can have its own private copy of a DLL, or Windows stores multiple versions in a special folder called Winchix. Also, security is huge. Windows now checks digital signatures on DLLs, so malware can't pretend to be a system file. And features like ASLR randomize, where DLLs sit in memory to stop hackers. So next time you click Save As or Print, remember, you're not running your app. You're borrowing a tool from Windows itself. That's code sharing, and it's been working for decades. Just smarter every year. Want to know how your RAM works? Hit subscribe, and I'll see you in the next one.